Hi, welcome to episode 3 of Out of the Blue. You'll probably notice our backgrounds changed, and that's because we're not going to be talking about basic math today. Today we're going to tackle the subject of gravity, and that's because I think it really is something that we have to know before we can talk about any other astronomical subjects. So, pun intended, let's get down to it. Before I can teach you anything about gravity, I need you to let yourself be taught. So if you hear words like relativity or space-time, I need you to not put up a wall and just let yourself learn the words without thinking that they're too complex or over your head, okay? Because I promise they're not, and they'll make sense if you just let yourself learn them, okay? Okay. What the heck is space-time? First of all, space-time is my favorite thing to say, because you can just be like, space-time. And it might sound weird, but I really like the way that sounds. Second of all, space-time is the fabric of our universe. That sounds kind of complex, but let's break it down into its individual parts, okay? So you have space, which is the three spatial dimensions, x, y, and z, length, width, and depth. And then you have time, which is the fourth dimension, and I think we're all aware of what time is, maybe too aware. Anyway, you weave all of these together, just like a fabric, and that is space-time. The universe is composed of space-time. We're all living spatially in the three dimensions that we have, and also going through time. That's the universe. It's best to think of it maybe as a 4D graph paper, but if that's kind of hard to understand, definitely just think of it as a fabric, sort of like a trampoline, stretched out, kind of stiff, but still fibers woven together that can be distorted and are distorted by gravity, which is what we're getting to right now. Are you ready? Because I'm ready. Got it? To explain gravity, I'm going to ask that you join me on a little bit of a thought experiment, alright? And please excuse everything about my drawing. So here we have a little guy orbiting the Earth in a satellite, as you can see here. This little guy isn't experiencing the force of gravity. He feels weightless. So he's not feeling any force down, and he's not feeling any force up. And he's not hitting the walls of the satellite, so he's not feeling any force from any side. No forces are acting upon this little guy, right? And we remember from physics classes that an object in motion not acted upon by a force is going to continue at a constant velocity. Velocity is both speed and direction, so a constant velocity would be the same speed in a straight line. This little guy is going in a perfect circle around the Earth, but he's not feeling any forces acting on him. That sounds like a contradiction, right? Because he should be going at a constant velocity, so this way, but he's going in a circle. What Einstein said was that he is going in a straight line, and this circle just represents a straight line along space-time. What happens is that space-time itself is actually curved around the Earth, because the Earth has such a high mass that space-time curves around it. And that curve of space-time, that distortion, that's what gravity is. It's just distortion of space-time caused by mass. Now I want you to go back to thinking of space-time as a fabric, just like before. Imagine a trampoline that still has a pretty rigid fabric on it, and imagine throwing something in the center of the trampoline. Now, the fabric of the trampoline kind of curves in, right, around the heavy thing, so that if you were to throw something smaller on it, like a marble, the marble would spin and fall into the heavier thing. Space-time works the exact same way, under the influences of gravity, and everything falls towards the heavier mass object, because it's distorting space-time, and objects tend to go along straight lines in space-time. Another thing that's important to remember is that space-time is a combination of space and time, so the more gravity there is, the slower time is, because it's sort of like stretching out space-time. And if that's over your head, that's okay. Just try to get gravity down as a concept first, and then work towards figuring out the implications for time. In conclusion, gravity isn't a force like Newton originally thought. It is a distortion of space-time. It's just curvy space-time. And it can be used to explain a lot of things. For example, black holes are really easy to explain using this fabric definition, and gravitational lensing, or Einstein's rings that you might have heard of, are really easily explained by gravity being curvy space-time. And I'll probably talk about one of those next week, so you should just leave in the comments whether you want to hear about black holes or gravitational lensing. I'll do either, I'll do both, who knows what I'll do. But thank you for watching, and I'll see you next week.